might need like 5 or 10 minutes early next class just to wrap it up, but then later on we will start inshallah a new material. So we discussed the abstract classes and interfaces in general, and we were trying to identify each. So we can say that abstract class is simply a class which defines the SE relationship. For interfaces, we can say this is a behavior description. So saying that this apple is a fruit, this is simply a class, but when we say this is edible, this is an interface. Now, technical features, we can talk about methods and how they are implemented. So abstract and non-abstract methods, we agreed they're part of any abstract class. For interface, we can include either abstract methods without actually a need to add this as a keyword. We have also static methods that could be fully implemented. Single inheritance support goes for an abstract class, so you can have two, let's say, or more classes inheriting from the same one. While for interfaces, it does support the opposite approach that's not usually supported in Java. We can have variables in abstract classes, but interfaces are meant to store constants. And of course, just like any class, we have constructors, while for interface, we can have no constructor. Okay. Now, array of objects. So this is one way of creating multiple objects in our code. How many objects do you see here? Two objects. And technically speaking, each of these objects will have its own space in memory, right? Okay, so when we try to call, let's say, this method, this code is not even there. But anyway, so these two for now, each has its own space in memory. Now imagine that I'm trying to optimize the process here and add it in such way. So I have a single array of objects. So this is now occupying a single space in memory, right? This space in memory you can split based on the total size of your elements. So this is total of 10 items. So now each of these indices, so let's say the first index or the second can be storing a whole new object separately. Now comparing this approach to this approach, which one do you think is better? They're both doing the same task, by the way. This one, why?
Which one is better?
This or this?
The first one.
First one? Why?
Doesn't have an doesn't have an array. Is this an array or in the
That's array of objects.
Yeah. So
Yeah.
This one.
Okay. Programmer wise? Programming wise?
I think so.
طيب.
Because why? Because there you are starting one array, but that has more than. Or maybe this is better because it's one array with more than one.
This is more optimized.
Yes.
Yeah, it's saying that because this is an array of 10 spaces and the rest of the spaces have like no values. So
Okay, so I mean not exactly the same case. You can still have it 2 or 3 as needed, right?
Oh.
But even if you have it, by the way, and it doesn't have any value yet, it doesn't occupy much of your space. So null values in general are troublemaker. We will see this later in database courses. But for now, space-wise, they don't occupy much. But you reserve the space later in case you want to push in additional objects. Well, actually, this ends the second review. So we're left mostly with the last review here, which is focusing on 2D and 3D arrays. So I'm sure you recall back these concepts. 2D in general, you can look into it as a table structure where you define this as row, this as column. You can think of it as a matrix or let's say a vector and so on. But in general, let's keep this rule in mind. Every dimension consists of dimension minus 1. So 2D consists of 1D. 3D consists of 2D and so on. So this is how, let's say, one-dimensional array was there, like position 0, 1, 2, and 3. But then now adding an extra dimension, this is how it's going to look like. So we have two indices now, one for row, one for column, right? Okay, so first one, this is row 0, column 0, row 0, column
1,
row 0, column
2,
and so on. This is what we refer to as diagonal, right? And you will see that both values here are the same. So R equals C, right?
Yeah.
Sorry. For the upper part, can you generate a condition? You see a relation between R and C?
it's getting larger.
Excellent. So I can say here that C is greater than R, right? How about this part?
C is less than R.
This is less than. Right?
Yes.
So these are in general the conditions that we can use to verify whether this item, let's say, is positioned correctly or not. Alright, can you tell me the position of the elephant here based on that? 2, 2. Snake. Okay, bird.
0, 1,
0, 1. Panda.
0, 2,
Dog.
0, 2, 2,
2,
1.
1. Excellent. Alright, we can declare arrays in two different ways. And you have the option of either knowing all the values before you start, or you don't know any of the values, right?
Mm.
So if you know it, you just need to list them one by one. And again, recall back this. So this is 2D, consists of 1D, 1D, right? So what you see here is, let's say, row 0, and first value, second value, and so on. Moving from one row to another, we simply use a comma, right? And also, delimiting all these values, we use comma. Once you're done, we end this with a semicolon. But again, this is entirely counted for as one statement. The other option is when you don't know these values. You will start with declaration, then you will initialize these values one by one, right? So you can say, for example, array that I call A, 0, 1 equals a given value, right? And this can happen part of a loop or a method, if let's say you're extracting the user input and so on. Alright, again, syntax-wise, it doesn't matter whether you put this empty brackets before the name or after the name, both are fine. And this is how you initialize any given index value. So again, these two are doing the same exact job here, but here you do it in a single step, one statement. But here, how many steps? 7. Total of 7 steps. Again, this approach is preferred if you don't know what to assign. So you keep this for later. Alright. Let me ask you a question. Is it always the case that I have the same number of columns in every row?
No.
No, we call this what? Ranged array, right? So ranged array is when you have, let's say, one row having, let's say, 4 items, the second having only 3, maybe 2, maybe 1. Okay, so it's irregular.
Yes.
When we say we have 4 by 4, even if you don't assign values, what's going to be added? So I filled this, I filled this, I filled this, and this. What's here? What's here?
None.
Depends on the data type.
Depends on the data type. So if this was of type string, this is gonna be
None.
null. Very good. If this was int,
0.
then this is 0. Again, double. This is 0.0 and so on. So based on the type of this array, defaults will be assigned. Now if I declare this to be rigid, in a sense, it's 3 items by 2 items by 1 item. Now any attempt to reach any of these elements, what will happen? Error? Huh? I need a better word.
Syntax not
Out of bounds. Array out of bounds.
Syntax not
Syntax? What? No, it's not syntax.
Array out of bounds.
Array out of bounds what?
No syntax, I'm not sure. Index not found.
Huh?
Index not found.
Index out of bound what?
Error.
No.
Exception.
Exception.
Oh.
Thank you. Difference between exception and error is what?
Exception is the run.
Hmm?
Yeah.
Is what? Sorry?
Exception will run.
Will run.
Yeah, it will
Okay.
not stop, but the error will not stop.
So you encounter the exception only when you reach that part. So it's known as what? Runtime.
Runtime error.
Runtime error. Exactly.
Exception, it can't be solved, but error.
Exceptions cannot be solved.
No, it can.
It can be solved.
Yeah.
Can be counted for.
Yes.
Right? So I'm expecting a user input, let's say on age. I know age is what type of value?
And
Int. Why would you why would you allow, let's say, the keyboard to be open? I might enter A, K, right?
Yes.
So being able to detect possible errors from the user side, you can simply count for exceptions. We'll talk about this again. So, okay, how many rows do we have here?
2.
How many columns?
1.
So this is, can you tell me the dimensions of that array?
2 by 2.
2 by?
1.
2 by 1?
2.
Huh? What
2
else?
by
2 by what?
2.
2? Okay.
It's one row, yes, 2 columns.
1 row?
1 by 2.
1 row, 2 columns, you're saying?
Yes.
What else?
What are you asking? What are,
I'm asking for the dimensions of this array.
the whole array?
Yeah, the whole
It's
array.
2 rows, 2
2
rows,
rows, 2 columns, so this is 2 by 2, right? We start, again, index 0. Sorry, 1, 0, 1, right? So 45.5, this is index
0,
0, 1. 11.3, this is index.
1, 2.
Very good. So here we're trying to update which value? 01 or 00?
1.
0, 0. No,
00, right? So we take this value, which is 45.5, times 2, this makes it 91, right? And then we save this into the index 00. So the one that gets updated is this one here.
Yes.
Very good. Okay, that's the same example, but again, we don't initialize a value for the 4th element. We only initialize these 3, right? So this item talks 0 by default based on the int data type. Okay. You remember scanner?
Yes.
So how would you extract user input? We simply import. We create an instance that uses system input, and then we utilize this input to extract, let's say, or scan the next integer value, double, float, whatever. So this is the rule. Based on the number of dimensions, we have listed loops, right? So 2D makes it 2 nested loops, and so on. So in 2D, one loop will take care of, the other will take care of column. How do we process? Do we go internal, then external, or external, then internal? So here's the rule. For every value of row, you finish all the columns. Yes? So here, we start with value what?
0.
We have 0, 1. We start with 0. Then, what's the value of column?
0, 0.
0,
0.
1,
1.
2, then 2 turns into
1.
false. Yes, because that's less than. See
Yes.
that? So once it reaches false, which one increments?
One.
So this exits
Outer loop.
and it jumps up and it increments from 0 to 1, right? Again, one repeats the same story. 0, 1, 2, false, right? Then exit, then increment this again. So 1 becomes
Two.
2.
False.
Then this again turns into false. So ideally speaking, how many times this loop runs successfully? We can say 4 times, right? But considering all false cases, this makes it what?
6.
No, 7.
7.
Oh,
This
yeah.
makes it 7 time iterations. Very good. Okay. So this is just like taking every value. We start with 1, we store it in 0, 0 at first. Then the next value will be 0, 1. Then 1, 0, then 1, 1. That's how you will fill the values in your array. Same would apply here for printing cases. So again, we go one by one for the print statement. Okay.
Doctor,
Yes.
when I open this PowerPoint in my laptop, it doesn't give me the same.
It's not the same.
Yeah.
PowerPoint.
Again.
When I open it in my laptop, it gives me a PDF version. It doesn't
Uh,
have all the animation.
Oh yeah, you want, yeah. Okay, so this weekend, just allow me some time. I'll be putting for you all PowerPoints, okay? But again, I'm putting for you PDFs for you to read all the notes I leave down. So as you will see, sometimes I put some comments to you.
Yeah.
If you use the PowerPoint, it's your responsibility. You need to check for these comments.
The comments can come there as well.
It is there actually. PDF, I mean, it's the easy way as you see everything.
All in one page.
Yes, but anyways, if you don't prefer this style, I'll add this for you as well. But again, double check on the side notes. Okay. How do we pass data in general related to arrays? Is it passed by reference or passed by value?
Reference.
Passed by reference. We agreed all arrays are passed by reference, which means any change applies to its core, right? So here I can print, let's say, values of this array using 2 nested for loops, starting from value 0 all the way to length -1, right? And here I'm just printing the value of I and j, like residing at this index I and j. How can I take this to external method?
What do you mean?
Okay, I want to extract this computation part into a method. Let's call it print array.
We need to create a
So first you need to generate a call, and then you build the method itself, right? My method is going to be, let's say, void, let's say, this is only printing, so void. Let's see, so this is the one. Let's say void print color. I have my 2 nested for loops inside. And this is the call I did. So this is the name of my method, and this is how I pass it the name of my array. Now colors and big colors, how different these two are.
big color is the one to test it first.
So can I use colors here?
No.
Why?
Because it's in the main.
Because it's in the main, local variable, right? Can I use big colors here instead?
Yes.
Yes?
No.
Mm.
It's in the print word.
Again, this is local variable. So X's code is once you declare it, so starting from here all the way to here. I can't use it in main. These two are reflection to each other, right? So P colors is in fact nothing but another name
Okay.
or nickname for colors. So any change happening to this one will affect this one as well. Okay,
Doctor,
please.
if we typed at the end return, will it be?
Now return generates that back to the caller.
Yeah.
Yes. but as a value. As a value, not as a value. So if you return, let's say, x, which was declared inside here, I can't go here and print x. So it's still gonna generate syntax error. But it returns the value of x. So what x holds, let's say value 5, this is now what you can deal with as a value stored, let's say, in any variable. Yes, that's a very good point. Now multi-dimensional arrays. So let's think of more dimensions. So we stopped at 2D, now 3D. Okay, do you know the difference between a 2D character and 3D character? What is that?
2D is to the
So 2D is what? Two axes.
X and Y.
X and
Oh.
Y. You can see it from a single angle, right?
Okay.
Think of it like a 3D now.
X, Z, and
So I can see X, Y, and
Z.
Z, right? So any object, let's assume it's a cylinder, right? You can now see it in 3D instead. Okay. So these are now the 3 new dimensions. We still have row and column. What's going to be the first one? Hmm? Okay. The first one here is going to be which array you are referring to. So this is how a 2D actually looks like. Sorry, 3D. So we have here first layer, which is 3 by 3 2D array, followed by another layer, which is also 3 by 3 2D array, followed by a third layer, which is again 3 by 3 2D layer. So how many total array do you see? 3 arrays. Each has how many rows? 3 rows. How many columns? 3 columns. That's the main idea. So this item has index what? This is array number
3. 2.
Mm. 2. Huh.
2.
Row number
1.
1.
Index 1.
Column number
1.
1. Right. Yeah? Type. How about this one?
2. 1 half.
1 or 2?
1.
1. 0.
1.
1. Nice. This one.
1. 0.
0. 2. 0.
Yeah.
Yeah? Again, we start from value 0. Keep this in mind.
Yes.
Okay. Like, let me, without showing you, you have to tell me now, what is this one? Tell me index.
1, 0,
1, 0. 1, 0 what?
1.
Okay, any other?
0,
0.
0, 0, 1.
0, 0, 1. Okay, any other? Huh. It is actually 0, 0, 1. So array number 0, row number 0, column number 1. Very good. How about this one?
Just inherit
Array number 1, row number
2.
1.
1 or 2,
1.
column number
2.
Very good. Clear? Okay. Again, we call back the concept. 3D array consists of 2D array, and 2D array consists of 1D array. Nice. So this one alone used to be a 2D, right? And this one alone used to be 1D. Okay. So now this is first 2D, second 2D, right? So 2 arrays separated by comma. Every one contains 1D followed by a comma, then the second 1D array. Okay. Again, you move here with the comma to concept, and then last one here is the semicolon. So now I have 2 2D arrays. Each is how many? Row by column? 2 rows. How many columns?
3.
3 columns. Starting from index
0.
index of 11 here?
1 1
1
1
1
1, 1, 1? Yes. 7? 1, 0, 0. Excellent. All right. So now we are growing to 3D arrays. We would need 3 nested for loops, right? So first one will take care of which array, then which row, then which column. Again, we start and out,
Yeah.
right? So for every value of the array, let's assume we start from 0. We start from
0
every value of the row. So this is your first 0. Finish all the columns. So this is
0
0, 1,
2
2. What to increment?
false
Of course, there is 3 which will turn
false
false. We keep this margin case. Type. After it turns false, then the one that increments is
array row
row or array?
row
Row. So this becomes 0 still. Now 1. Yeah? Then
0
again repeat. 0,
1 2 3
1,
1 2
2, then 3 which will turn
false
false. Now which one increments?
row
Again row. This turns into
0 2
2. And then what happens? Again false. Now what increments after? The array. So this becomes, and you will repeat the same again. So for 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 2, right? Then you increment again this one, so it becomes 1, 1, 0, 1, 1, 1, 1, 1, 2. And of course you count for false cases as you will. So same example, 1 to 3 all the way to 12, that's how it's gonna be traced. So 1, then 2, then 3, 4, 5, 6. Then it will end this array, jump to the second one, move again, row, then columns. So 7, 8, 9. This column's this row is over, and it will move to 10, 11, and 12. All right. Okay, I'll stop it here. We're only left with the exception part. I know you covered exceptions before, but this time might be slightly different. We will have some types of exceptions that we will see part of this course, the SE220, okay? So mostly focusing on the file system. We will return back to them afterwards, but we will just introduce them next class. I think we will need only 10 minutes, then we will proceed. Are you aware of Volvo car failure?
no
Okay, we'll see this inshallah next time. Are you aware of NASA rockets failure? Like what happened? What do you think is the main cause?
the one that came back
Yeah, I think there were multiple cases, but one of which failed after 10 seconds of launch. It just exploded in air. You know what was the key reason behind it?
they didn't program it
First production.
What?
they didn't program it well
Okay. Actually, the silly reason behind it was a rounding mistake. Rounding, just a round mistake. You know, when you say 0.00, let's say 2, or 0.002, something similar. It was that silly.
Oh.
And it caused a crisis that costed a lot of millions.
Oops.
Like 10 years minimum of effort and work and cost and resources, just due to a very simple exception. So dealing with critical systems in general, whether cars, medical systems, things or tools, let's say, that are part of surgeries, like things that would affect people's lives, it would require a double thought of the way exceptions are coded and handled, because that might prevent a crisis later on. We'll discuss this inshallah next time. For now we're done. I wish you happy weekend,
Thank you.
and we can stay next week.